Today, we are going to evaluate the integral of 1 plus x squared over the square root of x with respect to x using the substitution method. It's a useful method for dealing with integrals of composite functions. First, let's think about rewriting the integrand to make it easier for substitution. We start by expressing the square root of x as a power of x. So the integral becomes the integral of 1 plus x squared times x to the power of negative 1/2 with respect to x. Next, let's distribute the x to the power of negative 1/2 in the integral. When we distribute, we get two separate terms under the integral: the integral of x to the power of negative 1/2 plus the integral of x to the power of 5 over 2 times dx. Let's break it down further by dealing with each term separately. First, we identify a substitution for the x to simplify our work. We choose u equals x to the power of 1/2. Therefore, do equals 1/2 x to the power of negative 1/2 dx. And we can solve for dx, giving us dx equals 2 times u do. Now that we have the substitution variables, we can see how the integral will change. By performing the substitution, we now have the integral of 2 times x plus 2 over u times do. Next up, integrate term by term. The integral of 2u is u squared plus the integral of 4u cubed is u to the power of 4. Finally, we back substitute our original x value for u by replacing u with x to the power of 1/2, and this gives us x plus 2 plus x squared, plus the constant of integration c. And there we have it. We use substitution to evaluate the integral of 1 plus x squared over the square root of x. Substitution allowed us to simplify and then integrate each term separately before back substituting to arrive at the final result of x plus 2 plus x squared plus c.